Hello, my name is Sim Mei, and this is a web fundamental course from the Medical Informatics Department and also Computer Science and Information Engineering Department of Fujian Catholic University. Here we have lecture 1. In this lecture, we are going to focus on the networking basics and the HTTP, Hypertext Transfer Protocol. And we're starting from the course introduction. Basically, in this course, what are the topics and also the schedule of this course. Then we get into the first important part, networking ABC. Then before we get into the HTTP, the Hypertext Transfer Protocol, we also have a short introduction on the web history. Okay. So let's look at our tentative lecture topics and schedule in this slide. And today, February 22nd, we have a syllabus and also social learning space and hypertext transfer protocol. As we mentioned earlier, we have a homework 0 due today. And next week we have a day off, the national holiday. And in March 7th, then we're going to have the HTML and also tools, Photoshop and Dreamweaver. And the next March 14th, we have a CSS, and you can preview the content from WC School. And also in that day, our 10 project team will be formed, initiate. And also in the right-hand side, these are the labs and some posts on the social learning space. And then next week we'll have the introduction on the JavaScript. That's a front end, very important front end language. And in March 28th, we have a DOM, document object method and event, which is going to associate with the JavaScript we have in previous week. And in April 4th, that's the spring break of automatic. And when we come back from the spring break, we have one course on the one lecture on the AJAX, asynchronous JavaScript and XML. Okay. And although here we have XML, but here in the May 23rd, we have one week just for XML and also related to technology like DTD, schema, XPath, etc. and so on. Okay. But here in AJAX, we'll mention a little bit on the XML. And the following week will be the midterm exam. Okay. Then the next week we have the jQuery, and you can get the preview from W School as well. And also React.js. Since the time is limited, we probably will not get into React Native. However, in the lab part, you might have React JS or React Native there. Then we get into the May. The first week of May, we have PHP. The next week, we have HTML5. Then the material from HTML5, mainly from WC School, and also there's a very good website called HTML5 Rocks, and that is where the lecture notes come from. And the following week, we have SQL. Actually, starting from May, we get into the server side. Okay, although HTML5 is a client-side technique, which is the integration of the JavaScript, CSS, and HTML and APIs and some more. However, HTML5 is just a term. Like you have all those front-end technology together. Okay, so we have HTML5 as a conclusion for all the previous fundamental front-end technologies. Then in the server side, in the backend, we have PHP and SQL. That's a database query, sequential query language. The XML, as we mentioned. And we have 3 weeks for term project demo and the presentation. And we have another exam, final exam in June 20th. So that's basically the tentative schedule topics for this semester. So next we'll get into the networking ABC, network basics. And before we get into the actual networking topics, we'll have a list slide. Today's network is kind of different from the previous one, but even for 20 years ago, in 90s, that's the last century. And in the textbook, we can already see some, like here, a picture frame connected on the network. And also here is a very small web server. And today we have all kinds of the development board, like Raspberry Pi and many of those like Link IT from MTK, and so all those development board, you can put on server on that very small device and web server. So then all these are connected to the network. Okay, and also in 20 years ago we can see there's a toaster. A toaster when it's connected to the weather services, then in the morning you can see your toast bread. There's either from the weather service, either a sunshine, today's weather sunshine, or just partly cloudy. So that's all the idea of the all things can connect it to network, not just the computer or not just your mobile phone. So even 20 years ago, we already got the idea of Internet of Things. However, today is actually a scope everyone can have the kind of the a watch, Apple Watch, or kind of the wristband, a glass, and so on. Okay. And the next thing we'll look at related to a network is concerning the metric unit. And so for this prefix and this very small unit, and then for this very large units, so for example, for milli, micro, nano, pico, femto, atto, zipto, yocto. So in one way, like the VLSI, and for those IC design, and for the speed, we go a very small unit, use a very small unit. And on the other way, when we talk about the storage or the speed, or network speed, then we actually from the kilo, mega, giga, tera, peta, dexa, zetra, yuta. Okay, so we have to know the scale actually affects the performance and the application development of the networking world. Okay, and also there are two metrics, those metric prefix we should know. Also, the distinguish between bit and byte, we should also have to have a clear concept, because those are everyone in the ITs has some basic IT background. We know that 1 byte has 8 bits, so 8 bit consists of 1 byte. However, in the communication and network, when we're talking about the bandwidth or communication speeds, then usually use bit. So that's a BPS, that's a bit per second. And when we talk about a measure of the computers or system or your mobile phone's memory or storage size, then in that, when we're talking about those things related to computer or storage, then we actually use a byte. So if you say that we have a 1 giga BPS, that for communication, that's 1 gigabit per second. And you might say that my storage has 256 gigabytes. That'll be the byte. That's a computer storage. So in the communication or networking area or the domain, we use the bit for our fundamental measure. Okay, that's one basic thing we should know. And also, before we get into a networking basic, we have to know that since networking and communication developed rapidly in the past decade or past 20 years, so the scale just changed as we have in the previous. The scale just go one way or the other very fast, and the system getting very complex. So we had to make the system a partition system to many layers, or make it a hierarchical classification like a tree. Okay, or we have a network on top of the other network that we call overlay, and this layering hierarchical and the overlay concept apply to software or hardware or firmware. Okay, and in between the layer, we have to have a interface between the neighboring layer and using API to access the data or access the resource from the under layer. And when we make a design, we have to analysis first, then design, then the design make an evolution, and we're going to evaluate the performance. Okay, and for those complex systems, then we have to define many parameters, variables, and all kinds of KPIs to measure the performance of reliability. So that's the nature of the network is complexity. Okay, and since you have so many layers, so we have to define some protocol, because those network nodes are not in the same place. Otherwise, it's now called networking. We have to communicate. So if I have to communicate with you, then we have to have an agreement. The agreement on the networking we call the protocol, or in Mandarin called 协定. Okay, the protocol basically idea is what I say you're going to understand, and I will going to understand what you said. Then we can communicate. So that's like a protocol, and some of those protocols can become a standard, but some are not. Okay, so protocol is different from the standard, but protocols make the node on the network can understand each other. Okay, and when we design a network, we're going to use a lot of tools and we have different roles in the network, like sometimes we are user, sometimes we are developer, like here. When we talk about web fundamental, on the web, many of those web applications there, and we're going to learn many develop technology that's for the role of developer. And also, network manager is another important role, because when we develop all kinds of software, service, applications, those applications need to be managed. Then the life cycle of the software can be longer. So in the network area, we have user, developer, and manager. So in this slide, you can see the complexity of the network. Then so that's the complexity of network and the metrics, and also on the edge of network, we have all kinds of devices. So here we go to really the networking fundamentals. In networking ABC, we have four ideas I want to share with you. The first one is the network edge. Earlier on the toaster and the picture frame, those already are Internet of Things. And we look at what are really we connecting with people, with the user on the network edge. We can all kinds of the mobile phone. We could have some wearable device, and those are all on network edge. And behind the edge, when we get into the network system, then all kinds of equipment we could not see. All today we can say those are in the cloud. So cloud computing and the IoT are two very popular area in today's ITs. And if we look at what are the edge stuff and the core in the network, then we can get into see what will happen in the network. Our network is not perfect, so delay and loss could be happen. So Then in network, we're going to also introduce the packet switch and the circuit switching concept. And in both type of network, it could have some delay, as could have some loss. Okay. Finally, the protocol layers. Okay. In today's network, what are the actual protocols layers? And they are for our reference. And in that case, we can divide and conquer each layer of the networking. So firstly, we look at the network structure. On network edge, those are, we say that we have mobile phone or all kind of Internet of Things device and or computer, or traditional computer and phone. Then what are the software on that those computer and phone applications? Okay. Now how about the cores, network cores? Those are actually network router. We say router in Mandarin is 路由器. Then, and this router can be connected to the network edge device. Can connect it together, say from one city to the other city, or one university to the other university. And so that's like a network of networks. That's a network core. And then also another term related to the edge is access network or physical media. That's from the device to the network. Sometimes we can have a wireless communication, like the Wi-Fi we use a lot, and like 4G, 5G, or like the Bluetooth, and those are a form of some kind of communication link with the network core device. And so also we can have wired connection. Traditionally, you have wired connection, and right now we use more on the wireless connections. If we look at the end system, as we mentioned, that those hosts run application programs and like web or email and at the edge of network. And so that this computer also on the edge, and this is a server and this is a client. So on network we could have the client server model. Okay, the client send a request to the server, and we don't really care on the network edge. We don't really care how these communications happen and how many routers go through. So we don't really care about that. We just said that a client send a request to server, and server provide a service or send some data back to the client. Okay. And we also can have a peer-to-peer connection. Peer-to-peer connection means that the many of those peers on the edge, they can kind of communicate directly with each other. Okay. That can, so each peer is also a client and also a server. So in peer-to-peer model means that it's not just client, it's not just a client. Client can be a server. Server is not just a server. Server can be a client. Okay, so put client and server together, then communicate with each other, then they'll come peer to peer. But in traditionally, like in web, and that's strictly in web area, that's just strictly follow the client server model, which means that on the browser side, on the client side, we use a web browser, even Chrome or Firefox. That's a client device, then connected to through the URL, like connected to a server. Then that server send some information back to the client. Okay, so in traditional internet, that's based mostly on the client server model. And the next idea I'd like to share with you is the circuit switching and the packet switching. Since on client and server, they don't really care how these data came out. However, there are two ways of the data transmission from one edge node to the other edge node. The first one is called the circuit switching. Circuit switching basically from this end device to the other end device, they reserve, like we make a phone call. Okay, we have to actually reserve our path from the source to destination, and then there's a link go through this router and this router and go through the router, then get to here. And for example, for this one, and want to connect it with this server, then they have to reserve some link bandwidth there. So So just like when we make a call, we have to build up a path, and that path dedicate to this client and also this server, or this client and this server. So you have dedicated resource, and this resource not sharing. Although physically they share one link, but logically, at this connecting period will have a dedicated circuit for our communication. And in this case, need a call setup stage, or need some time for set up the call, because at the beginning we don't really know what test we're going to through, which circuit we're going through, and we have to set up and establish the test, then go through this particular test. If we're talking about the how to share that one particular link, for example, in here, in this link and this link and this link and this link, they are actually shared by multiple circuits. In that case, physically we could have, say, for example, the frequency division multiplexing, like here, divide by frequency. That physical is one line, but like our radio, right? Radio station or TV station, one line, but there are many different frequency. Each frequency band concerning one user and one station that take this bandwidth. Okay, so that's called frequency division multiplexing. Also, we can do this on the time domain. Then we can have time division multiplexing. Then what about, because here the x-axis stands for time, and just now we have a frequency division. Then for each user, they can transmit all time, and in this way, in 4 different frequency. The other way is time division. You can use all larger frequency band. However, we have 4 users. Each user will be sent in a small segment of time. So, and you send something, then you wait for 3 periods, then send your own destiny slot, then wait for 3 slots, then send 1 slot for 3 slots, and similarly the other, like the green one, also send in this period this slot, then wait for 3 slots. So that's called the time division multiplexing. So in circuit switching, we could have a frequency FGM and division multiplexing, and also the time division multiplexing. That's a circuit. As long as we need a dedicated circuit, then we can use those kind of technology. Actually, there are many. This can be applied to many transmission. And for next, we'll look at how we measure the loss and delay. And this is done at the packet switching scenario. Just now we have a circuit switching demo. Here in the packet switching, which means that we don't really have a dedicated link. For here, just like the solution, we have 2 stations. One to transmit data from this router and to that destination router. Then the this A and B, they have different color of packet send out. Then depend on the compatibility of this router, and this router cannot send all the packet at one time, so they have to be queued within the router and the buffer of the router. So packet arrive depend on the send out rate from A or B. Then when they arrive link, and this link between this router and the destination router, they might exceed the capability of the send. So this will be queue up. Depend on the arrival sequence, then queue up in here, and wait for the turn. So packing will arrive and queue there. Then when packet sent out, then packet actually might delay for these queues, and for and also with others packet. It send out. Then here's the transmission delay. We'll see that later also. Okay. Then if the too many packet arrived here, then packet, because the router do not have enough buffer to keep those the packet, then the packet might be lost. So that's the loss and delay might occur in the packet switch network, because the packet are sent out depend on the router's capability, also the rate of the sending to this router. So the packet delay might come out is by four sources. First, the node processing, because in each router you can look at the computer. Then it's going to process the packet coming and need to check bit error and determine which output link. Here we only have one output link. It could have more than one output link. But secondly, the packet is queuing here, so I have to waiting for the output link for transmission is queue up right here, and it might be congestion, right? Congestion, and then the data will be lost, as we have earlier in the previous one. The data might be lost if the router do not have enough capability, enough buffer. In fact, it's expensive router, it might have larger buffer. And the third source of the delay is the transmission delay. Transmission also the capability. If the CPU of the router is really capable, then it can send out transmit the data out quite fast. So that's transmission delay. If not, otherwise it will be slow. Okay. Finally, the propagation delay. That depends on the length of the distance between these two routers. If you have longer, you have from the say the Taiwan to US, then this is a very long distance. Then the signal propagation will be significant. If you send it from say Taipei to Taichung, then the propagation delay is much more smaller. So that's the data actual propagation time. Okay, finally, the very last concept, the protocol. Okay, the current protocol we use most is the Internet protocol, or as we say sometimes it's a TCP/IP. Okay, the protocol. We can in general make this as 5 layers: application layer, a transport layer, network layer, link layer, and the physical layer. The application layer support networking of application. For example, the FTP, that's called File Transfer Protocol, SMTP, and also the HTTP. We're interested on the Hypertext Transfer Protocol. And the next is the transport layer. The transport layer protocol is a host-to-host data transfer. Host-to-host transfer, most famous one called TCP and UDP. Actually, the HTTP is on top of the TCP. And it's a connecting-oriented protocol, and UDP is a connection-based protocol. We'll talk about this more when we get into the HTTP protocol. And underlying on transport layer is a network layer. Network layer is routing those datagram or packet from source to destination. And right now we use IP and also IP protocol, Internet protocol. So sometimes we call the Internet today is called TCP/IP. It's a TCP from the transport protocol, transport layer, and also the IP from the network layer, or TCP/IP. And the one layer beneath is called link layer. The link layer is data transfer between the neighboring network element. Today, like Ethernet, in our computer room, usually connected by Ethernet, and that's a data link. Actually, the Wi-Fi also follow the Ethernet protocol, like the wireless in there. The very bottom is the physical bit on the wire. So these why we have this kind of the protocol stack is because each layer has its particular functions and goals. So if we have this kind of partition, then for example, like usually in the operating system, it supports transport layer and network layer. Okay, and link layer basically is a network card. a communication, a hard communication board. Okay? The application layer mostly are the application system. Okay, it's not part of the operating system's application, and always support this transport layer and network layer. Then let's make the whole communication task be partitioned clearly. Then we can develop corresponding software for each layer. And this is the very last one side of the networking ABC, and also the idea of encapsulation. Here you can see on the top, this is a source computer, and this is a destination computer. On each computer, we have here we say have 5 layers: application layer, transport layer, network layer, link layer, physical layer. And in between here we have the network department, and this switch are layer 2 switch. We have physical layer and link layer, and this is a router. Router usually we say layer 3 router. In general, a router are layer 3 router. You can look into IP packet. So that's support up to the network layer, link layer, physical layer. So from the on top, this says, for example, we're going to access send out connecting to a web server. Then from the browser, the browser is on the application layer. We type a URL, HTTP, and so on. Then that's basically your browser will send up a HTTP message out, but not directly to other computer, but downward to your operating system. Then your operating system, your TCP, your transport layer, will add up a header and make it a TCP segment. Then one layer down, also in the operating system, then your IP layer will add up some more headers together with the segment sent from the transport layer. Then that become an IP datagram. Then IP datagram still within the operating system. Then one layer beneath to a link layer. And the link layer, then your network card will add up another header. And that make it become a frame. So you see your original HTTP, your URL, and those are some other information browser group together are actually already in the bottom of this message sent out. And all these, the message segment, datagram, frame, are called protocol data unit, or PDU, protocol data unit, each layer. So we can say that the protocol data unit link layer is called frame. Protocol data unit network layer is called datagram. Protocol data unit in transport layer is called segment. And also protocol data unit in application layer is called message. And sometimes confused, but the idea is just that data unit is different layer, has a different term. Okay. So when we get the source get done, so your request still within your computer or your mobile phone. Then we send out to the first switch, maybe in the computer room. Then you'll find out if this information, this server you request is in the same computer room or not. If not, then you send out to routers. So it's like in our university, you send out to other universities, a server in our university. Then the router in our we'll check, and where it go, then the IP layer, the network layer, say, then maybe go through many other routers and get to the destination router. So here maybe not just one router, maybe many routers, and that should be discussed in your computer network course. Okay, so maybe not just one router, many routers. Then eventually it goes to routers and eventually get to switch and get to a destination. That destination go the other way around. You get a physical layer signals, then the network board get the link layer frame, the data frame, then up to a network layer, then become the IP datagram, then up one layer up, then get to the TCP segment. Then on the top, that's the HTTP message. What means that on this kind of site, your web server receive a request from that user's browser. So if you are a user, a browser send information, send the information out, then go through all this way to the server, and the server similarly get the other way, send the web page HTML back all the way back to your browser. Okay. Then in these ideas concerning the protocol layer and also the data encapsulation, then this is quite important when we starting learning the network. Okay, so that's pretty much the networking fundamental I'd like to introduce to you at this part. Then we can take a short break.